Good morning to one and all. Myself, Dr. Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR IT, Hyderabad. I welcome you all. Today's session on testing of hypothesis concerning two means for large samples. In the last session, we have discussed the testing of hypothesis concerning one mean for large samples and the problems on one mean large samples. In one mean large samples, we use jet test. Now, coming to the overview of today's presentation, today we will discuss the test of hypothesis concerning two means large samples and we solve some problems on the same. In test of hypothesis concerning two means, we check the difference between two means. So, this test is also known as test for equality of two means, whether the two means are equal or not. So, this we can check by finding the difference between the two means. So, the test is also known as test for equality of two means. Test of hypothesis concerning two means large samples. In this also we apply the jet test. Here, since the test is related to two means, there will be two populations. For example, population 1, population 2, and the mean of the first population, that is denoted by mu1, mean of the second population mu2, standard deviation of the first population sigma 1, standard deviation of the second population sigma 2. So, here we have two populations having the means mu1 and mu2. Here we test whether these two means are equal or not. How can we test whether these two means are equal? If we calculate the difference between these two mu1 minus mu2, if this difference is 0, simply we can say both the means are the same. Otherwise, not equal to 0 or less than 0 or greater than 0. For example, if mu1 minus mu2 is less than 0, that implies mu1 is less than mu2. So, the mean of the second population is greater than that of first population. If mu1 minus mu2 is greater than 0, that implies mu1 is greater than mu2. The mean of the first population is more than that of second. So, now we consider two samples, sample 1 from population 1, sample 1 and sample 2 from population 2. And let us find the mean of this first sample and denote it by x1 bar and mean of the second sample denoted by x2 bar. Using these two sample means, we test whether the two population means are the same or not. So, this test is called test of hypothesis concerning two means or the equality of two means. Now, the test follows the following steps. As all of you know, the procedure of testing of hypothesis involves 6 steps: the null hypothesis, alternative hypothesis, level of significance, critical region, the region in which we reject the null hypothesis, and calculation part. Here we consider the test statistic, and finally the decision. In test of hypothesis concerning two means for large samples, we test whether the two population means are the same or not. So, that means we consider the null hypothesis H0 as mu1 minus mu2 is equal to 0. Equal to 0 means mu1 equal to mu2. Both the populations are same. Both population means are equal. And we test this null hypothesis against the alternative hypothesis mu1 minus mu2, the difference between the two means is less than 0 or greater than 0 or not equal to 0. So, we test the null hypothesis mu1 minus mu2 equal to 0 against the alternative one of these three alternative hypotheses. And the third step is level of significance, and the most general values for alpha are 5% and 1% level of significance. Next, coming to critical region. The region in which we reject the null hypothesis is called the critical region, and the conditions are the same which we have followed in testing of hypothesis concerning one mean problems. So, if alternative hypothesis is of less than type, reject null hypothesis if the calculated value is less than negative value of the tabular value. Similarly, If the alternative hypothesis is of greater than type, reject the null hypothesis if the calculated value is greater than tabular value of Z. And in not equal to type, the test is called two-tailed test. The critical region lies on both tails of the distribution. So, alpha by 2 area lies on left side, alpha by 2 right area lies on right side. That is why in not equal to type there will be two conditions, we have to use this alpha by 2. In one tail test, the level of significance or the region is alpha, whereas in two tail test it is alpha by 2. So, reject H naught if Z calculated is less than negative value of Z alpha by 2 or Z calculated is greater than positive value of Z alpha by 2. So, depending on the calculated value, if it is positive, check with the positive condition, if it is negative, check with the negative condition. Now, coming to the fifth step, calculation. Here we consider the test statistic. As I told you in the last session also, the test of hypothesis concerning means follows Z distribution only. So, even for one mean or two means, for large sample we use Z test. So, the test statistic is given by Z calculated value is x1 bar minus x2 bar by under root sigma 1 square by n1 plus sigma 2 square by n2. Here, in fact, in the numerator we consider the difference between the sample means minus difference between the population means also divided by the denominator value. So, here our assumption that mu1 minus mu2 is 0, that is our assumption or null hypothesis. So, let us substitute mu1 minus mu2 equal to 0 here. Hence, the formula is x1 bar minus x2 bar by under root sigma 1 square by n1 plus sigma 2 square by n2. Using this formula, we calculate the value of Z calculated and then compare this calculated value and tabular value and take the final decision whether to accept the null hypothesis or reject the null hypothesis. Now, let us discuss one problem related to test of hypothesis concerning two means for large samples. Now, consider this problem. In a random sample of 100 tube lights produced by company A, the mean lifetime of tube lights is 1190 hours with standard deviation of 90 hours. In a random sample of 100 tube lights produced by company A. So, there are two companies A and B. The mean lifetime of tube lights is 1190 hours with standard deviation of 90 hours. This is the information regarding the first sample from company A. Similarly, a random sample of 75 tube lights produced by another company B, the mean lifetime is 1230 hours with standard deviation of 120 hours. So, here we have two companies capital A and capital B, and from A sample of size 100 is taken. So, N1 equal to 100 and from company B N2 is 75 and the mean lifetime of the first sample is 1190 hours. So, X1 bar is 1190 and X2 bar here it is given 1230 hours and the standard deviation of the sample S1 is given 90, S2 is 120. And now the question is, test whether there is any difference between the mean lifetimes of two brands of tube lights at 5% level of significance. So, the level of significance alpha is also given 0.05 and we need to test whether there is any difference between the mean lifetimes of these two brands or not. So, that means the alternative hypothesis H1 is of not equal to type. Here we are not testing whether the brand A is better than brand B or the company B is better than company A. Simply we need to check whether the two brands are the same or not. So, alternative hypothesis is of not equal to type. Now, using this sample data and the procedure of testing of hypothesis given in the last slide, we can test whether the two means are equal or not. Here in the formula we need to substitute the sample mean, first sample mean, second sample mean and variances of populations or samples also. For example, if sigma 1 is not given, you can replace it by S1, sigma 2 by S2. If the variances or standard deviations of population are not given, we can replace them by corresponding values of sample. So, here in this problem S1 and S2 are given. So, we replace sigma 1 by S1 and sigma 2 by S2. Now, coming to the test, here the null hypothesis H naught. Our assumption is there is no difference between the two mean values. So, mu1 minus mu2 equal to 0. That is, both means are equal. That means there is no difference between the two brands of tube lights. Alternative hypothesis. Just now I told you we need to check whether the two brands are same or not. So, against the alternative hypothesis not equal to 0, mu1 minus mu2 not equal to 0. Level of significance is given alpha 5%, so which is equal to 0.05, and critical region, here we write the condition when we reject the null hypothesis, when we accept the null hypothesis. And rejecting null hypothesis, reject H naught if, since it is not equal to type, Z calculated is less than minus Z alpha by 2 or Z calculated is greater than Z alpha by 2. So, if our calculated value is negative, check with the first condition, and if it is positive, check with the second condition. And using the reference table of Z distribution, for 5% level of significance, plus or minus Z alpha by 2 or plus or minus 1.96. This is the tabular value. Now, coming to the next step, calculation part. The test statistic is given by Z calculated is the difference between the two sample means. Now, once again, here we have x1 bar is 1190. So, 1190 minus x2 bar is 1230 divided by under root S1. S1 is 90, S2 is 120. So, 90 whole square by 100 plus 120 whole square by 75. So, here the data is S1 is 90, S2 is 120. The size of the first sample is 100 and second sample is 75. Since sigma 1, sigma 2 are not given, we can replace them by S1 and S2. The size of the first sample is 100, second sample is 75. And by calculating this value, we will get minus 2.421, which is a negative value. And to take the decision, since our calculated value minus 2.421 and compare with the negative value of tabular value minus 1.96, which is less than, that means Z calculated is less than minus Z alpha by 2. So, here if Z calculated is less than minus Z alpha by 2, we can reject the null hypothesis H naught. That means we are rejecting the null hypothesis. That means we have to accept the alternative hypothesis that yeah, there is some difference between the two brands or the two mean lifetimes of two brands of tube lights. So, that is our conclusion. So, like this we test the given statement using the procedure of testing of hypothesis, which involved 6 steps. Similarly, let us discuss one more problem on testing of hypothesis, two means for large samples. Now, here it is a practical example. To test the effectiveness of a new pesticide on rice production, a farmland was divided into 2 equal parts, each of 30 units. The new pesticide is applied to 30 units, while the old pesticide to the remaining 30 units. So, this 30-30 gives the size of the sample. N1 is 30, N2 is 30. First sample and second sample. Now the question is there any reason to believe that the new pesticide is better than that of old? If the mean number of kilograms of rice harvested per unit using new pesticide is 496.31 kilograms. So, using the new pesticide, the mean kilograms of rice harvested is given. So, X1 bar is given 496.31 with standard deviation of 17.18. So, S1 is 17.18 kilograms, where using the old pesticide these values are, so X2 bar is 485.41 and standard deviation S2 is 14.73. Now, we need to test whether the new pesticide is better than the old. New pesticide is better than the old. And the test is as follows. First, the null hypothesis H naught. So, mu capital N minus mu capital O is equal to 0. This mu capital N denotes the mean kilograms of rice harvested using the new pesticide, and mu O denotes using the old pesticide. So, here the condition is the null hypothesis must be always in the form of equal to 0. So, therefore, mu 1 minus mu naught equal to 0. There is no difference, that is, there is no difference between the two pesticides. We test this against the alternative hypothesis that it is clearly mentioned. We need to check whether the new pesticide is better than that of old. So, mu n minus mu naught is greater than 0. That implies mu n is greater than mu naught. So, that is new pesticide is better than that of old. And the level of significance is alpha equal to 5%, which is 0.05, and the critical region, since it is greater than type, reject H naught if Z calculated is greater than Z alpha. For 5% level of significance, Z alpha is 1.64. This is the tabular value. Now, let us calculate Z calculated value using the test statistic x1 bar minus x2 bar by under root sigma 1 square by n1. Here x1 bar we have, x2 bar we have. Since sigma 1 and sigma 2 are not given, we can replace them by s1 square by n1 plus s2 square by n2. And the data is 496.31 minus 485.41 divided by under root 17.18 whole square by n1 is 30 plus 14.73 whole square by 30. So, if you calculate this, we will get 2.63814. The positive value, and our tabular value is also positive 1.64, and the final decision, since our calculated value 2.63814 is greater than the tabular value 1.64, Z calculated is greater than Z alpha. So, the condition is satisfied. Hence, we reject the null hypothesis H naught. If we are rejecting the null hypothesis, it itself means that we have to accept the alternative hypothesis. So, our final conclusion is, hence, the new pesticide is better than that of old. Since the calculated value is greater than the tabular value, simply we reject the null hypothesis that there is no difference between the two pesticides. If we are rejecting null hypothesis, it means that we have to accept the alternative hypothesis. And what is the alternative hypothesis here? The new pesticide is better than that of old. Hence, the new pesticide is better than that of old, and it gives more number of kilograms of rice per unit. And coming to the summary of today's session, in this session we have discussed the test of hypothesis concerning two means for large samples. In two means for large samples also we use the JET test, and we have discussed two problems, and in the next session we will discuss about the test of hypothesis concerning one proportion for large samples. And thank you very much.